Hey everyone, and welcome back. Till now we covered most of the containers and also we covered time complexity and space complexity. So let's cover two more containers in STL, which is list and forward list. Okay, they are similar to the vector and array, but there is one difference that make them different than the vector and the array. So it is on the memory. So let's say you have this block of memory. Here you have a small blocks of memory. Okay, so you have an array which have a values array or vector. Okay, so whenever we create array or vector, it is used continuous memory. So let's say it is using this for storing 2, then it will store this for storing 3, then 4, then 5. Okay, so that means it is taking continuous blocks of memory. Okay, but in case of list, this is our list. Okay, this is our forward list, this is our list. So we had this is our memory. Okay, so whenever we are storing data in list or forward list, it can store data randomly at any memory location. But for the vector or array, it needs a continuous allocation of memory. So the benefit of the list and forward list is you can store them in a memory randomly. You don't have to have a continuous memory to store the data. And also some of the operations we were doing in a vector and array in a big of and in list, those operation can be done in a big of 1. So the list and the forward list stored in a memory in a random position, but now we are saying they are stored in a random position. So how are they going to track of the list, right? Let's say if you have stored one data here, one data here, and one data here, and one data somewhere else, right? So you cannot make a connection in between them. So this block we call them nodes in list. So nodes store data and pointer. Means this, if we talk about first block, it is storing data as well as pointer to the next data. Means it is also storing the memory location or memory address of the next data. Similarly, this block storing the data itself as well as the memory location of this next block. So in this way it can make a chain of data in a memory. Now here you can see this is our forward list. In forward list we have only one arrow which is moving forward because it is storing data and pointer, or we can say next pointer, means this one, right? So it is called simply linked list. There is a term linked list, means the concept I explained about nodes and the pointer. It is a concept of linked list itself, and the forward list and list are implemented in a linked list itself. Okay, now this is our list. It is implemented in doubly linked list. Here you can see we have two arrows, means it stores data next pointer as well as previous pointer. Okay, so it is storing data as well as the next pointer and the previous pointer also. Okay, so our list and forward list are implemented based on linked list, and linked list are similar to arrays and vector, but arrays and vector store data continuously. Linked list store data in a form of nodes, and our node contains data as well as pointer to the next data. So we can place the nodes randomly in the memory and still can access them using pointers itself. Now let's see how we are going to declare and use list. Okay, so to use list we first have to declare it list, then we have our data type int, then variable name, then we can initialize with some data. So it is similar to vector itself. Now we can also perform operations. Let's say if I want to add data, so I can write list dot pushback of 40, so it will add the data at the end of the list. Similarly, it also contains push front, means here you can see it is a list, right? And list is a doubly linked list, so it can make connection both sides. So we can also include data at the front. So the time complexity of pushback is big of 1, and that push front also big of 1. Similarly, it also have pop back and pop front. right? The time complexity, it is similar. So initially we had a list 10, 20, 30. We pushed back 40, so 40 included here. Then we pushed front 5 included here. Then we removed 40, then we removed 5. Okay, we can also traverse in the list. We can use our range based loop. In list and forward list, we cannot use our standard index based loop because the indexes are used for a continuous data, right? While we are indexing, we writing 0, 1, 2, 3. These are continuous, but the pointers are not continuous in a list and forward list. So that's why we cannot use index, right? If you are saying it is at 0, you don't know what is the index for this block, so we cannot use our index based loop. Now why the list is useful in vector? When we are trying to insert element in the middle, it was taking big of n in vector, right? But inserting in list only take big of 1. So here inserting takes n, here inserting takes 1. So this is huge difference in a time complexity. So to insert in the middle or at index in list, we cannot say index, we can say position. So to insert at position 2, we have to write first pointer, which is our l dot begin. Right now we will write advance it 2, means pointer was here, then we said advance by 2 position, means iterate by 2 position. So it will come here, and now we can insert our data. So it will become like this. Okay, so the iteration will take time complexity, but insertion only takes 1. Okay, because we have to iterate on a list, so it will take, or worst case we can say n, or insertion only will take 1. Similarly we can remove, so we can write remove and we can put any number, so it will remove all the occurrence. If we have a 20, 20, 20, it will remove all of the 20s. Its time complexity is big of n, because in worst case it has to remove all the values. Means if we have all the values of 20, 20, 20 in a list, then it have to remove all the values, so its time complexity will become big of n. Now the limitation, we can say it has no random access, means this is our vector. Okay, 1, 2, 3, 4. Let's say I have to access value 3. I can write 0, 1, 2, 3 at the index of 2. It will print this value, right? But I have a list here, and if I want to access this value, I cannot do it. So there is no random access in a list. Let's run this example first, then we will move forward to the forward list. Okay, so first let's declare our list, and when we have 20, then 30. Let's add value at the back, and let's add 40. Okay, let's use our loop for auto it of l, then see out of it, see out of handle. Okay, let's print it. Here you can see it is printing 10, 20, 30, and also added 40 at the back. Now let's add l dot push front of 5. Let's run it. Here you can see initially we had 10, 20, 30, 40. Now 5 also added at the front. Then let list dot pop back, list dot pop front. This will remove our back and front value, so it will become 10, 20, 30. Now let's insert value at a position. To insert value at a position, we first have to declare a iterator which is starting from the beginning itself. Then we will advance, means we will traverse first or move to the position of 2, then we will insert. Let's insert 80. Okay, let's run it. Here you can see it is inserting 80 after the second position. Okay, now let's remove l dot remove of 80. Let's remove 80 itself, and let's run it. Here you can see it removed 80. Okay, so these are the functions we can use in a list itself. If you want to access a value at some position, right, you have to advance to that position, then you can access it, right? Let me comment this, and let's see out handle. Here you can see it is giving me an error. Okay, let's add star here and we can access the value at the end position, right? So if you want to access a value at a certain position, you first have to declare a iterator, then you have to advance to your desirable position, then you can print it using pointer, right? Because it is a pointer, means it is storing memory address, so you have to access the value, you have to write a star then pointer. Okay, now let's look at the forward list, how we are going to declare it and what are the functions we can use. Okay, to declare a forward list we have to write forward list. Okay, so we have to write forward list, then data type, then variable name, then initialization. Now if you have to insert a value, you will write push front of 0. Okay, in forward list push back is not allowed because it is a singly linked list. Okay, so it is moving in a one direction, so you can only insert in the front, you cannot insert at the back. Similarly we can use our loop itself, which will print all the values. It also has a function to insert after a position, means you have a forward list of 1 2 3. If we want to insert a value after this 2, so to insert a value after 2 you have to first declare a pointer which is starting at the beginning, then it has its own function which is insert after. Okay, so in this case we are starting our pointer from the beginning and it at the beginning itself, so it will insert a value after 1. Okay, similarly it has a erase after, it will erase value after the pointer. It does not allow pushback, it does not allow pop back, also there is no size function, it allows only forward traversal. So if we make a list, let's compare them, list, and this is our forward list. Push front we can do in both of them, push back we can do in a list but cannot do in a forward list, pop back list not in a forward list, traversal bi-directional means it can traverse from beginning to the end and to the beginning itself. It allows forward only, random access means using end access, no. Okay, and one more thing, memory uses, this use more and this is use less, means in a forward list we have a singly linked list, means it is making only one connection, but what is the doubly linked list, making two connections, single connections here, so it uses less memory. Double connections here, so it uses more memory because a single node storing previous pointer also. So this is our comparison. Okay, let's run all these examples. Okay, so I'm going to use same code. Let's make some changes. Forward list. Okay, here you can see it is giving me that pushback is not allowed, so we will comment it. Pop back also not allowed, so we will comment it. Okay, let's run what it will give. Okay, it is printing 30, means it is printing after the position of 2, so we can also use advance here. It also removing means we inserted. Okay, let's insert 80 also. Here 80 is not allowed, sorry, here insert is not allowed, so we have to write after. Okay, so insert after is allowed, now it is not printing. Okay, we are removing here, so it is printing 80, so we can remove and we can also use erase after, right, if we want to erase at a position. Okay, let's remove all of them. Now let's insert after, then write iterator, then the value itself, right? Okay, let's run it. Here you can see it is inserting a value after the first pointer, means it at the 10, then insert after is inserting after the 10. Let's say we want to insert after 2. Okay, we cannot write like this. So if we want to insert after advance it by one more position. Okay, let's advance to one more position and here you can see it is inserting after the 20, so we advance our pointer by one place, so you can advance or traverse using advance also. Similarly you can erase after. Okay, these are the function mainly we can use, pop front, push front, then we can advance and insert after. Similarly we can also L dot remove, we can use remove, also we can use erase after of it. Okay, so this will erase our value of 90. Okay, so that's it for the list and the forward list. The forward list and the list do have their own disadvantages but as well as advantages as compared to the arrays and vectors. So thank you everyone, have a nice day.